Good afternoon. In last lecture, we have started our next chapter, that is for IEEE standards. So we have covered some of the basic part related with the IEEE standards. That what is IEEE, what is the purpose of this particular organization when it is established, and related things we have seen in last lecture. Okay. So quickly, I'll show you some of the things related with the IEEE. So it stands for Institute of Electrical and Electronics Engineering, or it is mainly established for the purpose of defining or use of some of the standards which are used in computer science and electronics world. Okay, so the IEEE is a professional association which develops, defines, and reviews the electronic and computer science standards. Its mission is to encourage technological innovation and excellence for the benefit of the humanity. So that we have seen in the last lecture. Then next part is actually standards. Which are the standards are there that we are going to see. So the first standard is IEEE 802.3. Okay, so the first standard name is 802.3. It is also called as the IEEE 802.3 Ethernet. Okay, so as you can know, so Ethernet is mainly used for the LAN purpose. So this IEEE 802.3, it is called as a Ethernet LAN. So it is used mostly in CSMA CD LAN. Okay, CSMA CD carrier sense multiple access with collision detection. So CSMA CD is used for the transmission of the frame. Okay, now whatever standards we are going to see, that is 802.3, 4, 5, and 6. For all these standard we are having some frame format, means what will be the exact format for a frame in case of the every standard, how the data is arranged in a frame. So that is there in every standard. So frame is what is mean by the frame? Can anybody tell what is mean by the frame? Hmm? What is there in the frame? So we have seen in the third chapter that this is the task of the data link layer. Framing is done by the data link layer. So what is mean by the frame? So suppose this is my data, that is hello, it is my data. So some fields are get added at the start and end of this particular data, and this whole thing is called as a frame. At that time I told you that what is mean by the frame and what are the its fields that we are going to see. So here is the format for the frame. Okay, so along with the data some extra fields are added at the start and end of the frame, end of the data, and it is called as a framing. Okay, so for every standard 802.3, 4, and 5, and as well as 6, for every standard some frame format is fixed, and that we are going to see. So you can see here it is the frame format for the 802.3 Ethernet, IEEE 802.3 Ethernet. So this is the data part. Okay, and these are the extra fields which are added at the start and end of this particular frame. These fields, these are fixed fields, and these are having some specific definitions that we are going to see. Okay, so what are these fields? I'll just tell you. So first field is the preamble, then SOF, that is start of the frame, then destination address, source address, length, then actual data, then padding, and checksum. Okay, so these are the some of the fields which are added at along with the data, and it is a frame format for the 802.3. So let's see what are these meanings of this every field. First field is the preamble. So preamble, it is a 7 octet pattern of alternating zeros and ones which are used by receiver to establish a bit synchronous. Okay, so what is this? It is a 7 octet pattern. So you can see here I have given the pattern. So like this it is there. So whenever your data is there, Okay, suppose this is my data, and whenever it is being transferred or it is being sent to the receiver, at that time this 7 octet pattern, it is added at the start of the frame. Okay, and it is called as the preamble. Now what is the purpose of this preamble bit? It is used just to synchronize with the receiver. Okay, so obviously it is first field, so obviously it will be with the sender only, and it is used for the purpose of synchronization with the receiver. Okay, so what it exactly does, it enables the receiver to synchronize and to know that data frame is about to send. Okay, synchronization concept, I hope you know. Synchronization means what? Sender and the receiver both should aware about what type of communication is happening, right? So this preamble field is used for the synchronization purpose. So whenever sender sends the frame, at that time this preamble bit will synchronize with the receiver, concluding that data frame is about to send. Okay, so obviously as it is the first field from your 802.3 standard, it is each frame starts with this preamble. So whatever frame is there, it always starts with this particular preamble bit pattern 10101010. Okay, now the start of the frame byte containing this pattern itself denotes the start of the frame only, because it is the first field. And for this preamble field, the Manchester encoding bit is used, okay, to represent the uh, encoding pattern. Okay, so Manchester encoding, what is this Manchester encoding? How the waves are drawn, can anybody tell? Encoding techniques we have seen. Okay, Manchester, D Manchester. So suppose this is my data 0 1 0. Okay, now Manchester encoding means what? Where should I draw this bit pattern? Yes, where bit pattern should be drawn? At the start, end, where? You can write the message also in chat box. Yeah, where it is drawn, where should I draw? Suppose 0 is suppose high to low. Okay, should I write like this? Where it is drawn? Manchester and D Manchester encoding. Yes, can anybody tell? Huh, where it is drawn? Yes, roll number 2. Roll number 2. Where it is drawn?
Yes, ma'am.
Yeah, where it is drawn? D Manchester encoding, Manchester encoding. Don't know. Hmm? Yes, anybody can tell? Hmm? So Manchester and D Manchester encoding, these are the waves. These are always drawn at the middle of the bit interval. Okay, so where to start? From the middle. So like this your wave should get completed. Likewise Manchester and D Manchester. And for remaining all, how it should get completed? So it should start from or the at the start or at the end of this particular bit interval, right? So in case of this 802.3, the data is represented by the Manchester encoding bit pattern. Means at the middle of this particular your bit patterns. So this always produces a 10 megahertz square wave for 5.6 milliseconds to allow receiver's clock to synchronize with the centers. Okay, so synchronization how it is done? So by using the Manchester encoding, which generates this 10 megahertz square wave and it is synchronizes with the sender and the receiver. So that is the use of the preamble. It is the 7 octet bit pattern. Then next is the SFD, or which is also called as a SOF, that is start of the frame, or the second is the start frame delimiter. So both is also correct. So SFD or SOF. So this stands for start of the frame delimiter, which consists of one byte and it contains an alternate pattern of ones and zeros, but ending with in two ones. Okay, so what it does, it is a one byte bit pattern now, and which contains alternate one and zeros, but it always ends with a two ones, and it is called as the start of the frame. Okay, so whenever such pattern, such bit pattern will be there, it is considered that from this particular bit pattern your frame is being started. Okay, so what will be the sequence? The sequence is 101010 and double one, because it is ending with the two consecutive ones, which is an actual start of the frame. Okay, this preamble bit is just for the synchronizing with the receiver, and it indicates that the frame is starting from this particular preamble bit, but actual frame is starting from the SFD by using this particular bit pattern. Okay, and which enables the receiver to locate the first bit of the frame. So obviously from this pattern your frame is started. Then next field is the destination address. So this field contains the address of the station for which the data is intended or for which data is being sent. So that is called as the destination address and the source address. These are the two concepts. So destination address and the source address, these are common for all the standards. 2.3, 4, 5, 6. For all, these two are the fixed. Okay, so this fields contains the address for which we are sending the frame. So that is called as a destination address. In case of the destination address, how it is written, that is also decided. So the leftmost bit indicates whether the destination is an individual address or the group address. Means what? Individual means what? Whether it is sent or the particular frame is being sent exactly to the end user, one user, or to the number of users, right? इंडिव्हिज्युअल ऍड्रेस मीन्स व्हॉट? फक्त एकच युजर असेल किंवा एकच एंड युजर असेल तर त्यालाच डायरेक्टली तो तुमची फ्रेम डिलिव्हर होईल. अँड ग्रुप ऍड्रेसेस मीन्स व्हॉट? ऍट अ टाइम सपोज द फ्रेम इज being sent to the number of users. So all these addresses will be there or will come in a group address, right? So it is indicated by the leftmost bit. Now what is this leftmost bit? See here. So if it is an individual address, then it is denoted by 0. Means what? Suppose my address is starting from 0, then it will be a individual address. Means there that frame will be sent exactly to the only one user. Okay, or only one destination. And if it is a group address, means number of end users are there, then it that address will start from 1. Yes, if it is 1, it indicates that it is a group address. Next fields will be anything. But if it is starting from 0, then it indicates that it is only one user, that is end user is only one, and if it is starting from one, then it indicates that there are number of end users, or frame is sent to the group of the destinations. Correct? So it is called as a destination address. Now the next bit means in the address. Okay, the next bit into the destination address indicates whether the address is globally administrated or it is a local. Okay, so this is all about the individual or the group first bit. Next, what it indicates whether the address is globally administrated or it is a local. Then how it is categorized. So if the address is globally administered, then the bit is 0, means after this again if it is 0, or here if it is 0, then it is globally. And if suppose it is 1 after this, then it is a local. Okay, and remaining 48 bits will be there, which are actually your destination address, which are used for the destination address itself. So total 48 bits will be used to indicate this particular destination address, out of which these two are indicating. First bit indicates whether it is a group address or individual, and the second bit indicates whether it is administrator or it is a local one. Okay, and remaining 46 will be the actual address of a particular destination node. Clear? Destination address, and this pattern or this thing will be remain same for all the standard. Okay, means for all 802.345, whenever destination address will be there, so that field indicates in a same pattern. Correct? Then next one, next field is which one in this diagram? Next one is the source address. So source address, it indicates, obviously what it will do, it will it will tell from where your frame is coming. Okay, that is the source address. So source address consists of 6 bytes, and it is used to identify the sending station. Okay, so as it is always an individual address, the leftmost bit is always 0. Why it is an individual address? Because sending message or sender will be only one. Okay, only one node will send a message to either only one user or number of users. So sender is fixed, that is only one sender is there. So always as like this one. So in case of the source addresses, leftmost bit is always 0, means all the source addresses starts from a 0, and remaining this will be same. If it is administratized or the local, again it is same. So only as it is only one source, so your source address will always start from a 0. Okay, so these are the two concepts, destination address and the source address. These are the two. After this, the next bit is a length in this frame format. Next field is a length field. Okay, so what it indicates, let's see. So this field is a 2 bytes in length. It is of 2 bytes. It provides the MAC information, and which indicates the number of client data type that are contained in the data field of the frame. Okay, so what it does, it just provides the MAC information. What is this MAC? Yes, what is mean by the MAC? MAC address, MAC layer we have seen. What is the long form of the MAC? What is mean by the MAC? What is MAC? Yeah, media access control. Is it correct, Rohit? Media access control. Access control is correct. Yum is wrong. Yes, media access control is correct. Yeah, Pratibha has given the answer. Medium access control. Rohit, only one word you had written wrongly. It is not media, it is medium. Okay, last chapter only we have seen this. The whole chapter is depend upon this. So MAC is a medium access control. Okay, so this length provides this MAC information. Okay, and which indicates the number of client data types that are contained in the data field of the frame. So this is the length field. It indicates the length of the data fields in the octet depending upon whether the frame conforms to IEEE 802.3 or any other standard. So that is given in a length. Then next is actual your data. Okay, so all whatever fields we have seen, length, source address, destination address, frame, or the start of the frame, so these all are come along with the data. Okay, to make one frame. So data is what? This block contains the payload field or payload data, means actual data, and it may be up to 1500 bytes long, up to 1500 bytes long. So that is data field. If the length of the field is less than the 46 bytes, this question is asked for the MCQ. Please remember. Okay, so what will be the minimum size of data? So minimum size of the data should be, or it must be, of 46 bytes. Okay, if the data is less than 46 bytes, जर सपोज डेटा आहे तो 46 बाईट पेक्षा कमी असेल तर काय केलं जातं? देन पॅडिंग इज डन. Okay, padding is done. Now what is mean by the padding? It is nothing but the extra fields are added to make the data up to 46 bytes, right? So this is called as the padding. So you can see here in this particular diagram, this pad field is given. What is the purpose of this? Minimum size of the data requirement is of 46 bytes. It is given 46 bytes. But if data is less than 46 bytes, then that much extra fields are added into the original data, and this is called as a padding, and it is done by the pad field. Okay, so if the length of the field is less than 46 bytes, then padding data is added to bring the length up to the required minimum 46 bytes. Okay, that is padding is used to ensure that the frame is long enough for proper data operation. That is called as a padding. Okay, so this is the next bit. Understood what is meant by the data and pad bits? So remember the size of the data. Minimum data size should be 46 bytes. If it is not there, whatever data is required to make the minimum data size, that much data bits are added in your data, and it is called as a padding. Okay, and the last one is the checksum. Checksum is just used, or it is the field which is available. According to me, it is available for all the standards. It is used for error checking purpose. Okay, so that is called as the frame checksum. So in case of the 802.3, CRC is used as a error checking for the purpose of uh, checking of the error. CRC, that is cyclic redundancy check. So 32 bit CRC is used to check the error in 802.3. For every standard, some other mechanisms are used to check the error. We'll see at that point. But in case of the 802.3, this CRC is used. Remember. Okay. Now this is the whole about the your 802.3 frame format. Everyone has clear with all these fields. Anybody is having any doubt, or should I repeat once? Yes. Any doubt? Each and every field is clear. Any doubt? Okay, repeat. Okay, I'll repeat. Okay, see. Shortly, I will tell you each and every field, meaning of each and every field. So, what is this 802.3? It is one type of standard which is defined by the IEEE. Okay, and it is specially used for the Ethernet. Okay, or we can say Ethernet LAN. Okay, so that's why it is also called as the 802.3 Ethernet. IEEE 802.3 Ethernet. It is called as. It is used for CSMA CD LAN. For the transmission purpose, it is uses CSMA CD. This is the frame format which is decided for the 802.3. Okay. Now, what is mean by the frame and what is mean by the data? So, in our third chapter, we have seen that the main task of the data link layer is to convert the data into the frame. Now, what is this conversion? So, along with the data, some extra fields are added at the start and end of the every data. प्रत्येक डेटाच्या स्टार्टला आणि एंडला एक्स्ट्रा फील्ड्स ऍड केले जातात. ओके, आणि ते पूर्ण फील्ड्सला काय म्हणतात तर एक फ्रेम. सो सपोज दिस इज माय डेटा हॅलो, हा डेटा आहे आणि याच्या अगोदर आणि नंतर काहीतरी एक्स्ट्रा फील्ड्स ऍड केले जातात आणि ह्या सगळ्याला काय म्हणतात तर एक फ्रेम म्हणतात. ओके, अँड ह्या एका फ्रेमचा फॉर्मॅट हा आहे. ठीक आहे. मग ह्या फ्रेम मध्ये कोणते कोणते फील्ड्स असतात? सो इन केस ऑफ द 802.3 दीज आर द फील्ड्स अँड इट इज चेंजिंग फॉर एव्हरी फ्रेम फॉर्मॅट. प्रत्येक स्टँडर्डला हा फ्रेम फॉर्मॅट चेंज होत राहतो. ओके, नाउ फर्स्ट इज द प्रिएम्बल. What is this preamble? So first, its purpose is to synchronize with the destination. Now, synchronization means what? By using preamble bit means by seeing the preamble bit, destination will understood that the frame is about to send. म्हणजे आपल्याकडे काहीतरी डेटा येणार आहे या सोर्स कडून हे कळतं बाय युझिंग प्रिएम्बल फील्ड. बट its format is fixed, that is alternate 10, and it is 7 octet format. Okay, 1 2 3 4 4 1 2 3 4 5 6 7 and 8. So this is the format for this particular preamble bit, right? So whenever this pattern will appear at the start, it will be the start of the frame, and from this destination will understood that some data is coming to us. First bit. Then next is the SOF, or which is also called as the start of the frame or start of the frame delimiter. Delimiter म्हणजे काय असतं? Separator. You can take it as separator. So start of the frame delimiter. So it consists of 1 byte. ठीक आहे, त्याचं साईज किती असतो तर 1 बाईट असतो आणि ह्याचा पण फॉर्मॅट फिक्स आहे, दॅट इज अल्टरनेट 1 zeros, बट लास्ट टू विल बी द 2 consecutive ones. ठीक आहे, so this is the frame format. So whenever such bit pattern will occur in a particular frame, it indicates that from this bit pattern actual frame is started, because from the preamble only destination will know that some frame is coming to us, synchronization, but from this actual frame will be started. Okay, so this is the second field. Then next is the destination address. Destination address means what? where the frame is going. ज्या नोडकडं फ्रेम जाणार आहे त्या नोडचा ऍड्रेस, दॅट इज नथिंग बट द डेस्टिनेशन ऍड्रेस, बट इट्स पॅटर्न इज फिक्स्ड. ठीक आहे, इट्स पॅटर्न इज फिक्स्ड. इट इज ऑफ 48 बाइट. 48 बाइट त्याचा साईज असतो, आउट ऑफ विच फर्स्ट 2 बाइट्स आर फिक्स्ड. First 2 bits are fixed. So first 2 bits what? First one, that is left one. It will be either 0 or 1. 0 means what? That address of the destination is individual. Means this particular frame will be received by only one end user. That is nothing but the individual, which is indicated by 0. Okay, then next, if it is 1, it means that this frame will be received by number of end user, that is group addresses. So it will be indicated by 1. So this is the first bit. After that, the second bit is reserved for administrator or local. Again, it will be a 0 or 1. If it is 0, it means that it is a globally administrator destination, and if it is 1, it means it is local. And remaining 46 bits will be reserved for actual destination address. Okay, so it is a 48-bit address pattern. So it is destination address. Now source address, so 46 bits as like a destination address, this will be same. 46 bits पुढचे same असणार आहे. Remaining 2 as like these two, first leftmost bit and after that. So as in case of the source address, there will be only one sender, so it will be always 0. Means source address will always start from a 0, remember. Okay, so that is first one. And so it is always 0, so it is indicated. And remaining, that is 1 0 for the local and the administrator, so that is same. If it is 1, then it will be a locally and local, and if it is 0, then it will be a global. So that is fixed. Okay, so this source address and the destination address pattern are fixed for every standard. Remember this pattern. After the source, next one is the length. Okay, this field is of 2 bytes and which is used to display the MAC information. Okay, MAC information means what we can say, which data type is used, or which what is there in the MAC address, what is the type of the client. So all that information is represented by the length field. After the length, actual field is a data field. Okay, where your actual information or data is inserted. So it is means it is up to 1500 bytes long, and minimum size of the data is again fixed, so it should be of 46 bytes. It should be of 46 bytes, but sometimes it may be possible that the data is not that much long, तेवढा साईजचा नसतो. So if the data is less than 46 bytes, then it has to become up to 46 bytes to made it some extra bits, some extra bytes are added in a original data. Okay, and this is called as a padding. Okay, so in short, padding is used to ensure that the frame is logged enough for proper data operation. So it has to make up to 46 bytes. Okay, so this is the next field. And the last one is the frame checksum, which is used for error checking purpose. And it is of 4 bytes long. Okay, so it is of 4 bytes long, and in case of the 802.3, CRC is used for the purpose of checking the error. checking the error. CRC is used. So this is the last field of the 802.3. Now, after the Ethernet data frame itself, there is an interframe gap of minimum 12 bytes of the data. Okay, this acts as a delimiter to ensure that the receiver knows the frame is complete before any further data is sent. What is the meaning of this? So this is these all fields are there for one frame. कशासाठी एका फ्रेमसाठी. Now after this first frame, for when the next frame will be sent or when the next data will be sent, there must be the gap of 12 bytes. 12 bytes चा gap असतो. Why? Because it will act as a delimiter, a separator, to ensure that after these 12 bytes, whatever data will come, that will be of second frame. तो कुठला असेल? सेकंड फ्रेमचा असेल. दिस इज माय फर्स्ट फ्रेम अँड दिस इज माय सेकंड फ्रेम अँड इन बिटवीन 12 byte gap will be there, and it is a delimiter or it will act as a separator between the two frames. ठीक है? Any doubt? Now it is clear for everyone? Yes? Okay, so it is clear now. Okay, so 802.3 is over. Now, in our lab manual or in our practical performances, we are having one experiment on this frame formats, that is 802.3, 4 and 5. Three frame formats we have to execute. So instead of going to the program, I'll first complete second frame format and then we will go for the program. Okay, because the program is quite lengthy, it will took time. So in tomorrow's lecture, because 2 hours lecture is there, in that I'll cover the program. So next standard is IEEE 802.4. Next standard name is IEEE 802.4. Can anybody tell me 802 family is, or what is the purpose of 802? There is a specific purpose for 802. What is that? For which purpose it is used? Can anybody tell? Yes? Can anybody tell? 802 कशासाठी यूज केलेलं आहे? Why every standard we are seeing which starts from 802? Yes, can anybody tell? Hmm? एट झिरो टूचं मिनिंग काय आहे? लास्ट एक लेक्चर, फुल लेक्चर आपण ह्या 802 IEEE वरती घालवले. After spending 1.5 hours on same thing, there should not be any doubt. Hmm? What is 802? Yes, tell me, what is 802?
802 is collection of networking standard, cover physical and data link layer, specification, technology, enhancement and wireless.
But what is the 802? It is okay now, whatever you had told. That is the purpose. But why this 802 is given? Why not 811 or 812 is given? Hmm? Why it is not given as 8010, 16? Hmm? Why, where the specifications are applied? So in that same lecture, I told you that whatever standard will come under 802, that all will be applicable for Ethernet, LAN and WAN. Sorry, LAN and WAN. So 802 is specifically designed for Ethernet standards, right? So 802 point whatever will be there, 4, 5, 6, 7, 8, 9, 10, 15, 20, whatever. So all that standard will be applicable for this Ethernet purpose. Remember it. Okay. So 802 family is specially for Ethernet purpose. Correct. So it might be you all are aware that uh, whatever concept we have seen. So all that are applicable for Ethernet. So 802.4 it is used or this standard is a token bus network, or it is designed for token bus network. Okay, what is mean by the token? So it is type of information, or it contains some information which is used or which is there along with the every node. Okay, suppose there are you can see here whatever nodes are available. Out of all these nodes, the node which wants to send a message or which wants to send a frame, that node should have a token along with it. Suppose node number 1 want to send a message, ह्या नोडला मेसेज सेंड करायचा आहे, तर त्या नोडला टोकन असणं गरजेचं आहे. Then only that node can send a message. Okay, so 802.4 it is specially used for a token bus network. Okay, then token is passed around the network nodes and only the node possessing the token may transmit. So as I told you, so token is continuously moving within this network, and the node which want to send a frame or which want to send a data, that node should have a token with us, and only that node can transmit the frame. If a node doesn't have anything to send, the token is passed on to the next node on a virtual link. Suppose एखाद्या नोडला जर डेटा सेंड करायचं नाही, फ्रेमच सेंड करायचं नाही, तर तो नोड काय करेल, फक्त टोकन नेक्स्ट नोडला ट्रान्सफर करत राहील. राईट. So such way token is passed or it is moving in a network. Now it is a popular standard, that is 802.4. It is a popular standard which is used for token passing LANs. In a token bus LAN, a physical medium is bus. So what is this bus? So this one, bus topology, ring topology, star topology that we have seen. So what is this bus topology? So single wire is there, and for that wire number of nodes are connected. So you can see here this one. So it is a bus topology. Okay. So same in a token bus LAN, a physical medium is bus or a tree, and a logical ring is created using coaxial cable. Now what is this logical ring? Ring means what? So just one node is connected to exactly two other nodes, and ring will be formed. So you can see here 3 is connected to 1 and 5, 5 is connected to, suppose this is 4 and 3, likewise. So every node should connected to two other nodes and it will form a ring like structure. So though it is a bus what we can say bus like structure or bus topology, it forms a ring like structure by connecting the two users, and the token is moving within this particular ring. So you can see here, so the token is passed from one user to other in a sequence, clockwise or the anti-clockwise. So in some of the books it is given that the station which is having the high number, okay, in a numerical order, so that station is having the token at it first. Okay, so suppose there are five stations are there, 1 2 3 4 and 5. So out of these five station number fifth will have a right of token first, and that station will decide whether to transmit or not at initially, and then 4, then 3, then 2, and then 1. Likewise, token is passed to every other station from 5th to 4, 4 to 3, then 3 to 2, and 2 to 1. Likewise, token is passing. Now, from 1, again it will go to the station number 5, right? Likewise, it is passed. So each station knows the address of the station to its left and right. So obviously, unless and until this is known, they will not able to form a logical ring. जोपर्यंत स्टेशन नंबर 3 ला माहित नाही की माझ्या लेफ्ट आणि राईटला कोण आहेत किंवा माझे दोन एंड युजर कोण आहेत, तोपर्यंत रिंग स्ट्रक्चर होऊ शकत नाही. सो एव्हरी स्टेशन शुड नो exactly two users, end users. The station can only transmit the data when it has a token that I already told you. ठीक है, समझला? So we'll stop here because lots of things are there in this particular frame format that we will cover in next lecture. इथपर्यंत समजलं? Is anybody is having any doubt? Token means what? It is like a coupon. ठीक आहे, और लाईक अ तिकीट. ज्याला कोणाला फ्रेम किंवा डेटा सेंड करायचा आहे त्या नोडला टोकन असणं गरजेचं आहे. मग हे टोकन काय असतं? सो आय शो यू वन फॉर्मॅट ऑफ द टोकन ऑल्सो व्हॉट इट कंटेन्स. सो दॅट इज कंटिन्युअसली मूव्हिंग इन अ नेटवर्क अँड द स्टेशन दोज हू वॉन्ट टू सेंड that station should have a token with us, then only that station can send. ओके, आणि मग हे मूव कसं होत असतं तर जस्ट एक स्टेशन दुसऱ्याकडे पाठवतो, दुसरा तिसऱ्याकडे, लाईकवाईज. So either clockwise, anti-clockwise, or in a numerical order. It can be anything. But book madhe it is given that it follows the numerical order, and the station having highest number, that station sends token first. Clear? Any doubt? Yes, any doubt? If you have any doubt, you can ask. Okay, I hope no doubt. So we will stop here.